Area of a triangle using trigonometry. So if you remember back to finding the area of a triangle is 1/2 the base times the height. Well, in the triangles we're going to be working with today, we're not going to have enough information to know the base and the height. So we're going to use a different formula, and it is this down here. The area of the triangle is 1/2 AB sine C. So let's figure out where this comes from. First of all, we have lowercase a's and b's. What is that talking about? So if you have an angle A, which is uppercase, across from it is side A, lowercase. If you have angle C, across from it is lowercase side C, and angle B across from it is lowercase side B. So whenever you're referring to a side, you refer to it as the opposite of its angle. So it's the opposite of whatever angle you're referring to, and it's in lowercase. So that's where the A and B come from. But why is there a sine C? Okay. In a triangle, we usually are dealing with the height. So the height would be from the topmost part to the bottom. So this right here would be the height. We don't know what that is. In the triangles we're going to be dealing with, though, we have a little bit of information. We're going to know one of our angles. So for this type of problem, let's just say it was angle C, because we're dealing with angle C. And we're going to know one side of the triangle right there. So using trigonometry, I could find the height of this triangle using angle C and side B. So if I wanted to use that angle and that side along with the height, that is an opposite and a hypotenuse. So if I were to just look at this specific triangle here that is being created with angle C and the height, I would have the sine of angle C equals opposite, which is height, over whatever side B is. So if I wanted to solve for the height, I would multiply both sides by B, and I would have that the height is B times the sine of angle C. So I can write that this height here is whatever B times the sine of C is. So why does that matter with our equation? Okay, so if you think of a triangle, area of a triangle is 1/2 base times height. So we already have the 1/2, that's right there. The base for this triangle is actually side A, so that's side A there. And then the height is this right here, B times the sine of C. So it is using the base times height formula. It's just we don't have enough information. We're going to be given side lengths and one included angle. So this angle right here is the included angle. Remember, that means it's in between. So your letters might not match up exactly with the letters on a given triangle, or it might not even have triangles. But what you're going to be dealing with is a side, an angle, and a side. So you're going to think of it like our side angle side, if you remember back to geometry. So it's in an included angle. In other words, the sides create that angle. So let's actually put this into practice. So here is our triangle. This angle is included because it is created by the two sides that we are given. So if I want to find the area of that triangle, what I'm going to do is 1/2 times, now A would be considered like the 15, the B would be considered the 12. It's basically the two side lengths that create the angle, and I'm going to multiply that by the sine of 31. So let's get my calculator going here. So we're going to go 1/2, so I'm just going to put that in as a 0.5. So 0.5 times 15 times 12 times the sine of 31. So I'm going to go 31 sine, and then I'm going to hit equals, and we have an area of about 46.4. So this has an area of about 46.4. And we have found the area just given two sides and the included angle. So this one actually happened to have letters. It was A, B, and C. So like this would be considered side A, this would be considered side B, this would be considered side C, and we were given angle C. So for this triangle, we don't have any letters, and that's okay, because what we are given are two side lengths and the included angle. So we can still use the formula for this, and we don't have to worry about what A, B, and C are because we know we have the two sides with the included angle. So the area of this would be 1/2 times 14 times 8, those are the two sides, times the sine of 72, because that is the degree of the included angle. So if I put that into my calculator, I'm going to go 0.5 again for 1/2 times 8 times 14 times the sine of 72, and sometimes my sine button doesn't like to actually click, and I'm going to get about 53.3. So that means that the area of this is about 53.3, and if I put my units, it'd be meters squared.